Hey there, welcome back to another Edpuzzle. In the last Edpuzzle, you reviewed how to find slope, and hopefully it was just that, a review from Algebra 1, looking at finding the slope. And today we're going to use the slope to write the equation for a line. So please have the notes printed. If you can't print them because you don't have access to a printer, at least have them pulled up on a screen next to you so that you can see what these are and then be writing your own notes that look very similar to these ones. You can always use your notes on the test, and we are going to have a test over this material at the end of next week. So make sure that you have some good notes. All right, here we go. Like I said, we are writing equations for lines, and I feel like the most useful and the easiest way to do this is to write the formula in point-slope form. So the point-slope form of a line looks like this. Y minus y1 equals m times x minus x1. All right, you need to memorize that. It's your go-to equation for a line, and it's actually pretty simple if you know what these values mean. Every equation of a line, if it has a numeric slope, will have a y and an x. So you'll see that that y and x is right here, right? The x1 that you see here and the y1 represent a specific point or a specific coordinate that the line passes through, right? So for instance, if this had been coordinate maybe 4, 5, it's a specific ordered pair point, then the value of 4 is subtracting the x because it's the x value, and the 5 is subtracting the y value. In both of these cases, and probably one of the more frequently missed parts of this, is you are subtracting from the x and from the y these points, right? So these are positive points that our equation goes through or our line goes through, but we are subtracting them when we write the equation, right? This m, just like we referenced in the Edpuzzle for 3.4, m is the variable that represents slope. So the m is the slope. Right, we're staying nice and consistent there. So let's say that for, I don't know, any example that we're doing like this, our slope is 3. So that means that we would put the 3 there if we were doing this first example. So all of these cases will look like y minus something equals our slope times x minus something. Every single one of these, and then we're taking our information and just plugging it in, right? As far as these examples go, they just give us the slope, which is really nice. We just plug it in. If you aren't just given the slope like you are here, and you're given a graph, then you can count rise over run like we talked about in 3.4. Or if you know 2 points on the line, you can find the slope doing your y2 minus y1 over x2 minus x1, right? So there's a couple of different ways that you can get the slope information. As far as a point information, they either have to put it right there on the graph for you, so you just look at it, or they tell it to you in the text. So you're not really doing any figuring to find a point. A point will be given to you. The slope may be given to you. If it's not, you can see it on the graph, or you can calculate what it is based on the information that you learned in 3.4. So all of these are going to be this form where you're swapping in the y1, the slope, and the x1 based on the information you have. In this case, your point is your x1, y1. So the x1 goes here. The y1 of 5 goes here. My slope is my m value, which goes here. Right? Every single equation for a line, if it has a numeric slope, is going to be written y minus something equals that slope, whatever it is, times x minus something. I can do the same thing here to get it started. It's just like a cookie cutter approach. Okay. So this is going to be x1 and y1. This is going to be your m. So x1 is always subtracting. It's x minus that negative 2, so it's actually adding 2. My y1 is minus 1, so y minus a negative 1. So you can think about that as like adding 1. And my slope is 1/4. You're just plugging it in. You're not distributing at this case. you want to look at it, and this is the form you want with its parentheses and everything else, because you can look at it if I gave you this equation and you could see the slope, you could see a point, and off you would go with plotting it or graphing it if that were what we needed to do. Today we just need to write the equation, right? So what would the point slope form of a line that goes through negative 5, 8 with slope negative 3/4 be? Well, again, this is x1, y1. This is your slope. We're plugging it in. Y minus y1, so y1 is 8, equals our m, which was negative 3/4, times x minus the x1, which is negative 5, so this changes to a positive, because minus a negative is a positive. Right? Memorize this, or at least know how to use it. Important. Because I think that this is the easiest equation for a line to use. All you're doing is finding a point. Any point can be any point on the line, and the slope. We already talked about how to find the slope. You're going to be given a point, maybe given multiple points. You only pick one. Plug it in and you're done with the problem. So like I said, you might be given multiple points. In these cases, you were only given one, but there are situations where you will be having to choose between which point to use, right? When multiple points on the line are known, you're going to use any 2 points to calculate the slope, y2 minus y1 over x2 minus x1. And then you can choose either point that you want to put into your equation. Right? If you have multiple points, your equations will look different, but they are going to be equivalent. And they're going to be equivalent because once we transfer from this point slope form into like a slope intercept form, you'll get the same answer. Your intercept will be the same. Your slope will be the same. So let's see what an example of that looks like. If I was looking at this graph here, and I wanted to write its equation, I'm going to pick 2 points to use. Again, I am recommending that you use the points that have the grids intersecting. It's not like here where you would have like fractional points and you have to estimate. Use the ones where they're actually spot on when they're intersecting. So it's intersecting here at 1, 4, and you can see here again at 2, 0, it's a solid point. So for our slope, if we have something graphed, it's just a rise over run situation. Will this slope be positive or negative? Hopefully you said it would be negative. It's going downhill. So if I start on the point on the left and then go down, 1, 2, 3, 4, it's negative 4 over 1. So if I just left it at negative 4, that would be fine because negative 4 over 1 simplifies to be negative 4. Now, this is my slope, so this is my m. I can use either point here. It doesn't matter. So if I used 1, 4, then this 1 would be my x1, 4 would be my y1. And if I plugged it into something like this where we were using, it's y minus y1, which is 4, equals my slope, which is negative 4, times x minus x1, which is 1. Right? Again, I am keeping y minus equals x minus, and that all the same every single time. I'm just swapping out this value, and this value. I got these two values from the point, and this value is my slope. This is the equation for this line. If I had written the equation for this line and instead of using 1, 4, I used 2, 0, so this would be my x1 and this would be my y1, it will look different because I have a 2 and a 0 instead of a 1 and a 4. So I get y minus 0 equals negative 4 times x minus 2. Right? Same thing as this is my y value, this is my slope, this is my x value. Right? These two equations represent the same line. They look different, but they're equivalent. Now, this is what I was saying earlier. They're equivalent because if I solve for y in both cases and get y by itself, I'll get y minus 4 equals negative 4x plus 4 if I distribute to get rid of my parentheses. If I add 4 to both sides, I get y equals negative 4x plus 8. Right? If I used this and got it into slope-intercept, remember we said slope-intercept was that y equals mx plus b, where if y is solved for the slope is multiplying our x, our slope is multiplying our x, our intercept would be 8. And if we look here, our intercept is 8. It's going through that y value of 8, so it holds. If we had taken this equation instead of this one, and again put it into slope-intercept form, we would get y minus 0, which is y. Distribute that negative 4, we get negative 4x. Negative 4 times negative 2 is a positive 8. In both cases, I end up with the same slope-intercept form. So this equation, or this equation are all valid equations to represent this line. There are actually an infinite amount of equations that represent any one line. It just happens that every single one of those equations will have the same slope, and it has to go through any one point. Since every line has infinite points, we can pick any point to use. It doesn't matter. They'll look different, but they are equivalent. Right? So if we do this one, what's our slope here? Well, pick any 2 points. I pick this point and this point just because that's where my graph is crossing through the intersection of the grids. And do rise over run, I get 1, 2, 3 up, 1 over, so my slope is 3. If I wrote the equation using the point 3,5, then again, this is my m, this is my x1, this is my y1. So I get y minus my y1 of 5 equals my slope, which is 3, times x minus my x1, which is also 3. Right? Hopefully you're noticing this pattern where this value is the y1, this is the m, and this is the x1. It asks me to put this into slope-intercept form. Remember, slope-intercept form is that y equals mx plus b. So I'm going to take this, and I'm solving for y. Okay. So when I solve for y, I've got to distribute. Okay, y minus 5 equals 3x minus 9. And if I add 5 to get my y alone, I get y equals 3x minus 4. All right, my slope is 3. This one now is saying that my y-intercept is negative 4. We can't see because the graph's kind of cut off where the y-intercept is, but it does look like it's going to be about negative 4. So this answer does make sense. In both of these situations, and all of these situations that we've done so far, we've had numeric slopes. So we've had both y's and x's when we wrote the equation. If you have a numeric slope and a point, then you want to write the point slope form. Right? Point slope form of the line works in numeric slope situations. Because in numeric slope situations, you're going to have both an x and a y in your equation. Remember from 3.4 that we said that horizontal and vertical lines don't have numeric slopes. Our horizontal line has a 0 slope, and our vertical line has an undefined slope. Remember, horizontal is side to side. Vertical would be up and down. Okay. So in these cases, it's the same type of problem where they give us a point and a slope, just like they did here, point and a slope. We had a numeric slope, so we went with the y minus y1 equals m times x minus x1. Here, we don't have a numeric slope. If we only have a slope of 0, remember that a slope of 0 means it's a y equals a number. The y value here is negative 1, so our equation is y equals negative 1, because that's what the y value is. Okay. If we knew that it had been undefined instead, remember an undefined slope just means x equals that number. So it's x equals, what is the x value of our point? Negative 5. So x equals negative 5. That's your equation. If you don't have a numeric slope, you don't have both x's and y's. You only have one or the other. So to keep them straight, remember OI and VUX. If you have a zero slope, it's only y. If you have an undefined slope, it's only x. What's your equation going to be here? Well, it's a zero slope. So it's going to be y equals, and what is the y value? -12. Right? Over here, the fact that it's undefined tells us it's going to be x equals. What is our x value here? 9. So if you don't have a numeric slope, you're only going to have one variable. If you have a number slope, these are all numbers, 3 1/4, -3 4, all numbers, they're going to be the slope, point slope form. If you don't have numbers, if you have 0 or undefined, then you just have an x or you just have a y. And you decide which one it is using those acronyms OI and VUX. If it's only a 0, it's a y equals. If it's undefined, it's an x equals. Okay. So now we've done equations for lines where we have a point given to us and a slope. We've done equations for lines where we've been given a graph. The third type that you can have is where you have to do an equation for a line and you just know 2 points. Well, if you just know 2 points, the first thing you have to do is calculate its slope. Remember that to find the slope, you're going to do y2 minus y1 divided by x2 minus x1. So if we do that here, we get, remember, x1, y1, x2, and y2. Just labeling them so I can put them into our formula. y2 minus y1 is 8 minus a -1. x2 minus x1 is 3 minus 4. So when I simplify, I get 9 over -1, which equals a -9. That's my slope. I can pick either point to put in for the equation. I'm just going to go with the 4, -1 because I've already labeled it x1, y1 to find my slope, so I'm just going to stay consistent. So I get y minus y1, which is -1. So minus a negative would be a +1. Equals my slope, which is -9. It's x minus the x value of 4. Right? So I'm just using x1, y1, and the slope and putting it back into that same equation. If I have a numeric slope, that's what my equation is going to look like. Right? You do this one. What's your slope? 12 minus 10 over 5 minus a -3 will give us 2 over 8. So my slope is 1/4. Again, I use this as x1, y1, and x2, y2. All that means is this is the x value of the first point that was listed. This is the y value of the first point. This is the x value of the second point, x2. This is the y value of the second point. Right? So I use this and this. No reason why I'm not using this, by the way. You can use either one. I'm just going to stay consistent. I've labeled this as x1, y1. I'm just going to go with it. Right? If you had put in 512 instead of -310, it would have been an accurate answer. So you get y minus 10 equals 1/4 times x plus 3, because minus a negative will be positive. All right, down here, if you notice before you even get started that your x values are the same, right? If my x values are the same, remember that all x values for ordered pair for a horizontal line will be the same. My x values are the same. Here they were different, right? But if they're the same here, that means that my answers for my equation is just going to be x equals 4. That's it. Right? If you didn't notice that and you went ahead and you did your slope formulas, you would have gotten a clue there too. If you did the slope formula, you would have got 3 minus a -1 over 4 minus 4, which would be 4 over 0, which would tell you anything over 0 is undefined. If it's undefined, that's that Vux situation where it's just an x value. Right? So if undefined slope, you can pick either point. They're both 4 for your x's, and that's your answer. It's very similar to what we did here. We just had 2 points that we had to get our slope first. But once we got our undefined slope, we just picked the x and said x equals that number. Over here, if you notice, before you even get started, that your y's are the same, your answer is just y equals 8, and you can be done. It's really nice. The horizontal and the vertical equations are pretty straightforward. So if you hadn't noticed that, though, and you just went blindly through and did the y2 minus y1, it's okay. You would still be given that clue, because if you did 8 minus 8 over 6 minus a negative 3, you get 0 over 9. Well, a 0 slope, you should hopefully be thinking OI. All right? So OI means to y equals. Y in both cases is 8. That's my answer. So you have three different things that could happen. You can have a numeric slope, for which case you do y minus y1 over, if you have a numeric slope, you have y minus y1 equals n times x minus x1. If you don't have a numeric slope, you could either have an OI situation or you could have a Vux situation. The slope of 0 is going to be y equals. A slope that's undefined is going to be x equals. And it's only x or it's only y if it's a non-numeric slope. All right? So hopefully you took some good notes and they can help you as you do your homework. If you need some help, don't hesitate to reach out. Have a good day. I will see you next time.